All right, guys, let's look at the product of powers property. Let's start off with kind of what this property looks like. What's the nomenclature? So here's what the product of powers property says. Let's say that we had some power x to the a times x to the b. So what this property says is as long as this power and this power, the two powers that we're multiplying, as long as they have the same bases, so there's the base, there's the exponents, okay? So here's a power, we're multiplying them, okay? As long as you're multiplying two powers or more, I shouldn't say two powers, sorry, we could have four powers, okay? However many powers you're multiplying, if they have the same bases, so the x is the same, right? The property says that we can just pass that common base along to our answer and we add the exponents. So it's kind of like a shortcut, right? So let's actually test some of these out. So let's do a new example here. So what if we had something like, let's say 4 to the third power times 4 to the eighth power, right? So we could go ahead and work that power out to its standard form number and then multiply those two standard form numbers, and it's going to give us a pretty large number, and we could do that. But we're learning the product of powers property, which is kind of a shortcut to a version of our answer, right? That's not in standard form. It's still going to give us an answer, but it's going to be in power form, right? So as long as the powers that we're multiplying, as long as they have the same bases, so the fours, right? As long as these are the same numbers, we can pass that common base along and we add our exponents. So 8 plus 3 is 11. And then we could go ahead and work for the 11th power out if we wanted to, but it's going to give us a really large number. We'll just stop there and say that's a good answer and leave our answer in power form. Okay, let's try another one. Let's do something with variables in it, right? So what if we had x, let's say, to the third power times maybe x to the 10th power, right? So our answer is obviously going to have to be a variable expression, but we can go ahead and simplify this, right? Because we have a power times a power, and the bases are the same. So we can therefore use that shortcut and just pass our common base along to our answer and add the exponents, right? So that's going to give us x to the 13th power. And of course, we don't know what x is. If anybody told us what to plug in for x, we could go ahead and plug it in and raise it to the 13th power. And that would be the same, right? That would give us the same answer as working each of these individual powers out and multiplying the individual answers. So again, it's kind of like a shortcut to the answer, right? Let's try another one. Let's get 3 in here. What if we had, let's say, like a times maybe a to the 5th times a to the, I don't know, let's go 6th. Okay, can we use our shortcut there? Of course we can, right? It doesn't matter how many powers we're multiplying, as long as they have the same bases, right? And we're multiplying them, right? Not adding, not dividing, not subtracting, right? This property only works for multiplying powers with the same bases. And you might say, well, this is not a power. It doesn't have an exponent. Well, let me let you in on a little secret, okay? Every single thing in the world, every number, every letter, every variable, everything has an exponent. If it doesn't have an exponent shown, it's automatically a 1, okay? So it does have an exponent. So power times a power times a power with the same bases. Again, we can just pass that common base along to our answer, and we add the exponents. So we're going to take 5 plus 1 plus 6, right? Any order, 1 plus 5 plus 6, doesn't matter. We're going to get a to the power of 12. There we go, right? Let's do one a little different. How about if we throw some constants in there? How about 4y, let's say, to the 7th times maybe 2y to the 3rd? No real difference here, right? We got to make sure we understand what's going on between these constants and the variable terms here, right? If you have a 4 sitting right next to the y with nothing shown in between, what does that mean? Well, there's automatically a times sign there, right? What's going on between the 2 and the y to the third? Well, there's nothing shown, so we have to assume it's a times, right? So everything is just being multiplied. There's no mixture in operations, really, so we could reorder these if we wanted to, right? So at least in our minds, I'll write this down on paper, but at least in our minds, if we didn't want to write this step down, we would think of it as being this. Right? So we could go ahead and take our 4 times 2 to get 8, right? So that's going to go ahead and work out to be 8. And then we have a power times a power there with the same bases. So we can go ahead and use our shortcut, right? So a power times a power with the same bases, y, right? So we pass our common base along and we add our exponents, 7, 8, 9, 10. And there we get a good answer. So we could just call our answer 8 times y to the 10th, or a little bit nicer, we just call it 8y to the 10th. How's that? Well, we just practiced some product of powers properties problems there. Hope that helps you out.